Getting a distinction is an option. Getting a credit is also an option. If getting a distinction is an option, why going for anything else? If getting a distinction is an option, why going for a credit? LS Online Tuitions is here to help you attain that distinction. Stay tuned and pay attention so that we can move together. In this video, we are going to learn atomic structure and reactivity. We are going to begin by looking at three components of an atom. Protons and neutrons are found in the nucleus. Electrons are found in the shells. In physics, under magnetism, we learned that opposite poles attract, like poles repel. In physics, under electrostatic, we also learned that like charges repel, opposite charges attract. Now, we want to know the reason. Why is this electron not falling onto the nucleus? In physics, we have learned that opposite charges attract. So we can see positive charges at the center of an atom, and we can see a negative charge here. So according to physics, there is an electrostatic force of attraction between these two components. Now, why is this electron not falling onto the nucleus? We want to know the reasons. Number one reason, electrons in the shells move at high speed. Now, what is happening to the force of attraction between protons and electrons in the shells? So we need to understand three types of forces. Force number one, forward force, force in the direction of the moving object. Number two, opposite force, force opposite to the direction of the moving object. Number three, perpendicular force. So we have seen that the electrostatic force of attraction is a perpendicular force. So perpendicular force has low to minimum impact on the moving object. So we have seen that this electron is moving at high speed. So the perpendicular force, the only effect or the only impact the perpendicular force, the electrostatic force between a proton and the electron has on this electron is changing its direction. So it is one of the reasons why electrons move in a circular manner. So we have learned that the reason why an electron is not falling onto the nucleus is because speed keeps this electron in orbits or energy levels or shells. Then the force of attraction to the nucleus is balanced by the same speed of an electrons. We also need to know the reason why electrons don't fly away. Why don't they fly away? Why don't they fly away? So number one reason, there is a force of attraction between the positive charges at the center and the negative charge in the shell. So this electrostatic force of attraction keep this electron orbiting around the nucleus or the force of attraction helps this electron to continue moving in the shells or in the energy levels. So we are going to say electrons are attracted to the positive charges in the nucleus. This electrostatic force of attraction holds electrons in the shells of an atom. So we have seen the reason why this electron is not flying away. It is because of the same electrostatic force of attraction. So we have seen that this same electrostatic force of attraction is only changing the direction of an electron. Changing the direction of an electron, upon changing the direction of an electron, it is also helping this electron to keep moving in the energy levels. Energy levels limit how far electrons can go. So one of the reasons why this electron is not flying away is because of the energy levels. Electrons are placed in their shells according to their energy levels. So the one near nucleus has low energy level. So these energy levels helps this electron to keep orbiting the nucleus by not flying away from an atom. The next thing that we are going to discuss is reactivity of group 7 elements. Group 7 elements are called halogens. They gain one electron during reactions. Reactivity changes down the group. So here are elements from group 7: fluorine, chlorine, bromine, iodine. Okay, so these are group 7 elements. Now we want to look at their reactivity. So we are going to begin by looking at their reactivity in terms of atomic radius. So radius is the distance between the center and the edge of the circle. So how does radius of an atom affect reactivity? So remember, we are from saying at the center of an atom, there are positive charges. In the shells, there are particles with the negative charges, which are electrons. So we saw electrostatic force of attraction between protons and electrons. So what conclusion are we going to make? Atomic radius increases down the group. So as we go down the group, atomic radius keep on increasing as indicated here. Outer electrons are further from the nucleus. So the bigger the atomic radius means more shells surrounding the nucleus. So the number of shells, as the number of shells keep on increasing, the reactivity keep on decreasing. So the bigger the atomic radius, the lower the reactivity of that particular element. Let us also look at the reactivity of group 7 elements in terms of electronegativity. Let us begin by defining electronegativity. What is electronegativity? Electronegativity is the ability of an electron to pull or to attract electrons. Is an ability of an element or an atom to attract, or a tendency of an atom or atom's tendency to attract electrons to itself. Or we can say atom's ability to attract electrons to itself. We are going to say electronegativity decreases down the group. Top elements attract electrons more strongly. Fluorine is the most reactive halogen. So we have seen that elements with a small number of shells are more reactive than elements with a big number of shells. So in our case, we have seen that in group 7, fluorine has the smallest number of shells surrounding the nucleus. So therefore, fluorine is the most reactive element in this group. We have also talked about the radius having a small number of shells surrounding the nucleus means having a smaller atomic radius. So we have seen that atomic structure and electronegativity are direct proportion. The electronegativity is direct proportional to the reactivity. The higher the electronegativity, the higher the reactivity of elements in the group. Then atomic radius is inversely proportional to the reactivity of an element. The smaller the radius, the higher the reactivity. The bigger the atomic radius, the lower the reactivity. To appreciate the importance of what we have learned, let us answer this question. And this question is coming from 2021 past paper. This question is question 3. Which of the group 7 elements is the most reactive? Explain your answer. The question is carrying 2 marks. So they want us to state the element which is the most reactive in group 7, and they want us to give the reason. So the element is fluorine. Fluorine is the most reactive element because it is on top. It has a small atomic radius and it has high electronegativity. Remember we said electronegativity means atom's ability to attract electrons to itself. Okay, so the reason that we are going to give, we are going to say electron is at the top of the group and has smallest atomic radius and has high electronegativity. So these two properties qualifies fluorine to be the most reactive element in group 7. We have come to a close. Just in case there is a question, you are free to drop it in the comment section.